Hello everyone, welcome to my channel. In this video we are going to discuss one of the very important questions, that is what is electrolysis and Faraday's first law of electrolysis, and finally we'll discuss one numerical problem based on Faraday's first law. This part is very important. Frequently you are getting question on Faraday's laws as well as numericals based on Faraday's laws. In this video we are particularly going to discuss only Faraday's first law. Faraday's second law will discuss in some other video. Here electrolysis definition, Faraday's first law statement, as well as one numerical problem based on Faraday's first law will discuss. Let's start. The question here we are getting in examinations are like this. So what is electrolysis? Give Faraday's first law of electrolysis. We have to define what is electrolysis and statement of Faraday's first law. Let's see what is electrolysis. It is a process of dissociation of a compound into its ions. The process of dissociation of a compound into its ions. That means the compound is dissociates into ions. So for example, if you take NaCl, one second. If you take NaCl, NaCl is dissociated into Na plus and Cl minus. Okay, when the process of dissociation of a compound into its ions in the molten state or in the solution state, means it's a pure state or in the solution state by passing electric current. Okay, dissociation of a compound by passing electric current is called electrolysis. Okay, that's the meaning of that. So to make you understand, I will explain this electrolysis process briefly. So for this, let us take a vessel. Let's take a vessel and let it be some beaker, and it is filled with NaCl. So suppose this is sodium chloride, NaCl, and we have placed 2 electrodes into this NaCl. Let's place 2 electrodes into this NaCl. The first electrode is this electrode is connected to positive end of the battery, and this is connected to negative end of the battery. There is a positive end, there is a negative end, and this acts as a anode, and which is carrying positive charge, and this acts as cathode, and this will have negative charge. And when we switch on the battery and electricity will pass into the solution, that is NaCl, then NaCl splits into Na plus and Cl minus ions. These Na plus ions are cations, they have positive charge. Cl minus ions are anions, have negative charge. Just before we discussed, anode is having positive charge, cathode carrying negative charge. Here cations having positive charge, cathode is having negative charge, right? That means cations move towards cathode. This Na plus ion move towards cathode, gains the required number of electrons and becomes Na. That means this positive charge and this negative charge get cancelled and it becomes Na. That means Na metal deposited at the cathode, sodium metal deposited at the cathode. So here sodium metal will be deposited because cations move towards cathode and deposited on the cathode. Whereas the Cl minus, these are anions, anions having negative charge, but anode is having positive charge. So anions move towards anode. The Cl minus ions move towards anode, and they lose electrons because Cl minus is having excess of electrons. It will lose electron and becomes chlorine gas, Cl2 gas, and releases that electron. By losing this electron, it becomes a neutral gaseous molecule. That means chlorine gas will be released at anode, sodium metal is deposited at cathode. And you remember one point, so metals always have positive charge. That means metals always form cations and they always deposited at cathodes. Chlorine, which are electronegative elements, will be released in the form of gas at anode. This is the complete electrolysis process. But here you no need to write all this process. You just have to write what is electrolysis. Electrolysis means when you pass electricity through an electrolytic solution or electrolyte, it splits into ions. Say for example, NaCl splits into Na plus and Cl minus ions. This process is called electrolysis, right? Next we will discuss Faraday's first law. So to understand Faraday's first law, we have to understand what is electrolysis. So just we discussed what is electrolysis, and similarly we'll continue our discussion to understand Faraday's first law also. So let us consider two different cases. In the first case, for example, I have passed some less amount of electricity, less electric current I have passed. In the second case, more quantity of electric current we have passed. Faraday observed that when we pass less quantity of electric current, less amount of substance will be deposited at anode or cathode, or when we pass more quantity of current and more amount of substance deposited at electrodes. That means the amount of substance deposited or mass of the substance is directly proportional to quantity of current we pass. This is Faraday's first law. The mass of the substance deposited at electrodes will be directly proportional to quantity of current passed. So mass of the substance deposited is equal to some constant, that is a proportionality constant Z. It is also called electrochemical equivalent into Q. This can be written as M is equal to Z and Q is equal to IT. Since Q is equal to IT, Q is current in amperes, Q is current in coulombs, whereas that is equal to I into T, that is current in amperes into time in seconds. That means the 1 ampere current per 1 second is considered as 1 coulomb. Therefore, M is equal to Z into IT. This is the simplest form of Faraday's first law. This can also be written as mass of the substance deposited is equal to equivalent weight of the substance into current in amperes into time in seconds by 96,500. This 96,500 is a Faraday, 1 Faraday value, that is 1 Faraday is equal to 96,500 coulombs. Now let's go to our material. So what's given in our material? So this is the statement. The process of dissociation of a compound into its ions in the molten state or in the solution state by passing electric current is called electrolysis. This is electrolysis definition. Very simple. The dissociation of a compound into ions by passing electric current. That's all. What is Faraday's first law? The amount of substance deposited at an electrode is proportional to the quantity of electric current passing through the electrolyte. Just we discussed briefly about Faraday's first law. If you pass more amount of current, that is more quantity of current, more amount of substance will be deposited. If you send less quantity of current, less amount of substance will be deposited. And the mathematical expression of Faraday's first law is mass of a substance deposited is equal to equivalent weight into current in amperes into time in seconds by 96,500. The same formula just I have given to you, that can be written very simply. Mass of the substance is equal to equivalent weight into current in amperes into time in seconds divided by 96,500. This is one of the very important formulae, and you just remember this formula. Next we are going to practice one numerical problem based on this formula. Here there is a question based on Faraday's first law. The question is, state Faraday's first law. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at cathode? Atomic weight of copper is equal to 63.6. This is the question. So the first part of the question is statement of Faraday's first law. We have to state Faraday's first law. Just we discussed Faraday's first law. The amount of substance deposited at an electrode during electrolysis is proportional to the quantity of electric current passing through the electrolyte. This is called Faraday's first law of electrolysis. That's okay. And next, the formula. Mass of substance deposited is equal to, so equivalent weight is nothing but atomic weight by valency. That's the formula for equivalent weight. Okay, let's substitute the values given in this formula. So mass of substance deposited is equal to, atomic weight of the substance. Atomic weight of copper is given in the problem as 63.6. Actually it is around 63.5. Okay, let's take any one of this. There will be no difference, much difference. 63.5, what is that? Atomic weight into current in amperes, 1.5 amperes, and the time in seconds. Actually time is given in minutes, 10 minutes. So 10 minutes is equal to 10 into 60, that is equal to 600 seconds. So time is given in minutes, so we have to convert the time into seconds. So time in seconds, that is 600 by valency of the copper. Valency of copper is 2, atomic weight 63.5 and valency is 2. Suppose if you don't know valency of copper, what should you do? Do you know any formula of any copper compound? So most commonly used copper compound is copper sulfate, CuSO4. So Cu plus 2, SO4 minus 2. What is the charge of copper here? Plus 2, no? That's its valency. The common valency of copper is 2. So 63.5 by 2. This is atomic weight, this one is valency. And 96,500, that as we have discussed in the problem. So after solving this, we'll get the answer around 0.2 approximately 0.2 something grams. But we'll solve this problem because in a public exam you don't have any provision for using calculators and all. So for such problems, how to do the calculation part? So I'll make you do such calculation very easily. Mass of the substance is equal to, the given values are 63.5 by 2, that is atomic weight by valency, into current in amperes 1.5 into time in seconds, 600 seconds we got, and 96,500, right? And here 63.5 by 2, 63.5 by 2 will get 31.75 approximately, and we'll take this approximate value as a 32. I'm not going to take 31.75 here. So 63.5 by 2 we get approximately 32 into 1.5 can be written as 3 by 2 into 600 divided by 96,500. But here I do one thing. This, instead of writing 96,500, 96,000, one second, 96,500 is approximately is equal to 1 lakh, isn't it? It is approximately equal to 1 lakh. 1 lakh is nothing but 10 to the power of, how many zeros are there here? 1, 2, 3, 4, 5 zeros. 10 power 5. So instead of taking 96,500, I am going to use 10 power 5. Whatever the method of this calculation I am explaining to you is also helpful for competitive examinations like IIT JEE, NEET, and even EAP set and all. So this is the way of doing fast calculation. So what I have taken, so instead of 31.75, I have taken 32. And one more point, the equivalent weight of copper is always constant, and it's better to remember copper 32 equivalent weight. Right, now do the cancellation part. So 2 ones are 2, 2 16s are 32, right? Now multiply all these three things, and this becomes 63 into 16 into 3. 16 3s are 48 into 600 into this 10 power 5 can be taken as 10 power minus 5, because 10 power 5 is in the denominator. If you take in the numerator, it becomes 10 power minus 5. That is equal to, here 600, 2 zeros are there, no? This 2 zeros means 10 square, and here 10 power minus 5 is there. So that becomes 10 power, if you cancel these 2 zeros, it becomes 10 power minus 3. So shall I write here itself? I'll write 10 power minus 3, 10 power minus 3 by cancelling these 2 zeros. Now I have 48 into 6 into 10 raised to minus 3. 48 into 3, 48 into 6, 6 8s are 48, 6 4s are 24, 24 and 4, 28 into 10 raised to minus 3. This can be taken as 288 into 10 raised to minus 3 can be written as 0.288 grams. 0.288 grams. Okay, so but what answer we got in our material? In our material we have 0.2. That is also approximate value, but you can write any one of these two value. Better to write after your calculation you got 0.288. So approximately we will get 0.288 grams. There will be no much difference even if you do the calculation in a approximate method. Okay, this is the fast way of doing calculation. Thank you. We'll meet in the next video. Be happy and be healthy.